Reactions of acids and bases. Okay, we've talked about these before. When you mix an acid and a base, you get a neutralization reaction. This is a type of double replacement reaction. The hydrogen and the hydroxide are getting together to form water. The potassium and the chloride are getting together to form the potassium chloride. And so that's how we looked at it before. Now we can look at it in terms of an acid and a base. So here's HCl. We can recognize that as an acid because it starts with H, but also we see that here's the chlorine. It has an H here, and over there it doesn't. It lost its H. It swapped it for potassium. Here's KOH. This hydroxide has become water. It accepted the proton from the acid. So this hydrogen ion went from the acid to the base, and the result is water and salt. If we write the net ionic reaction for this net ionic equation, we're going to get H plus OH minus, giving us H2O. That's the net ionic equation for most neutralization reactions. Here's the reaction between HCl and sodium hydrogen carbonate, or baking soda. And a similar thing will happen if you mix vinegar with baking soda, and that is something that you could do at home too. When we mix an acid with hydrogen carbonate, we get one of those gas evolution reactions, and what's the best way to do this? See, what we would expect if we just did swapping, if we just swap the partners here, the hydrogen and the sodium, we would expect to get sodium chloride and H2CO3. H2CO3 is carbonic acid. It's unstable in water, and it's going to fall apart. It's going to give water and carbon dioxide. So if you have acid reacting with a carbonate or a hydrogen carbonate, then your net ionic equation is going to be a little different because there's a gas that gets given off. And we talked about those in a previous chapter. But mostly we're going to look at non-gas producing neutralization reactions. So write a molecular equation for the reaction that occurs between aqueous H3PO4 and aqueous NaOH. And then there's a hint there. See this formula H3PO4? I told you that the acidic hydrogens are written first. Here there's 3 of them. That tells us that for phosphoric acid, it will actually release all 3 of its hydrogen ions. And so that's called a triprotic acid. Hydrogen ions are protons. This one has 3 protons that it will release, so it's triprotic. A diprotic acid is something like H2SO4. It'll release 2 hydrogens. Things that just have 1 hydrogen that they will release are called monoprotic. So H3PO4, and that's going to react with sodium hydroxide, and they want an equation for this. Acid-base neutralization reactions are a form of double replacement, and so that is often the best way to predict the products. What ions does this form? Well, it forms hydrogen ion and phosphate ion. Sodium hydroxide is composed of sodium ions and hydroxide ions. They're going to swap partners. This is the acid. It's going to donate a proton. This is the base. The hydroxide is going to accept the proton. So over here, we're going to get sodium with phosphate, and we're going to get hydrogen ion with hydroxide ion. And when you put these 2 together, you get a water molecule. It's very good to write the formulas for the ions with their charges, because when you put sodium and phosphate together, you have to consider the charges to write the formula. Sodium has a +1 charge, phosphate has a -3 charge. You can't just put one of each of them together and have a neutral molecule. You need 3 sodiums. So this is Na3PO4. So we've got our products. Is it balanced? No. This is a triprotic acid. It can donate 3 hydrogen ions. We need 3 bases to accept this. This babysitter, this base here, can only accept 1 proton. Now, some babysitters can handle more than 1 child at a time, but a lot of these bases can only handle 1. So we're going to need 3, 1 for each kid. That's going to get expensive, isn't it? But if you had 3 3-month-old babies, you'd probably be willing to pay, because that would be triplets, and oh my goodness. I have 6 children, but they came 1 at a time. I have great sympathy for anyone who has multiples. That's above and beyond. So 3 bases for the 3 protons. And that takes care of our sodium problem here. Now we got 3 sodiums from there, but that's going to form 3 water molecules. Multiple ways of thinking about how to balance that equation, but we should all end up with the same answer. Any questions? Yes?
Why did you move the 3 from the H up to the PO?
This is phosphate ion, and we know that phosphate ion has a -3 charge. We could figure that out from this formula too, because each of these hydrogen ions, and there's 3 of them, each hydrogen ion has a +1 charge. This is a neutral molecule, which means the positive charges from the hydrogen balance the negative charges from the phosphate ion. So it's got to have a -3 charge. Any other questions? Acids dissolve many metals, but not all of them. You mix HCl with, I'm pointing in the wrong place, HCl with magnesium, you get hydrogen gas and magnesium chloride. You mix acid with zinc, you get hydrogen gas and zinc sulfate. HCl will dissolve iron, again releasing hydrogen gas and forming a salt. So acids dissolve many metals, but not all of them. We did a reaction like this in lab, where we generated hydrogen gas and collected it. Do you remember that one? And what was left in the eudiometer after all the bubbles stopped? What happened to that piece of metal? It was gone, right? Because it formed an ionic compound and was soluble in the water. Acids can also react with metal oxides, and when they do that, they produce water and the salt. So writing equations for acid reactions. Let's write an equation for the reaction of hydrochloric acid with strontium metal. Well, what's the formula for hydrochloric acid? HCl. And strontium is Sr. So an acid reacting with a metal, we're not going to go into how you would know if it reacts or not, so you can safely assume that whatever I ask you to write an equation for actually will react. So this is H plus and Cl minus. What's going to happen here is we're going to get hydrogen gas. And then what's left? We're going to have an ion. I'm pointing in the wrong place again. We're going to have an ion from this. What ion does strontium form? Positive. It's in group 2, so it's 2 plus. So the hydrogen ions are going to form hydrogen gas, And the strontium is going to form an ionic compound with the chloride. The chloride doesn't change, and so in order for these charges to work out, this has to be SrCl2. So we're looking at the charge on the metal ion from the periodic table. This is the anion from the acid. And then we have to balance it. 2 hydrogens here and only 1 there. So we need 2 HCl. And that takes care of it. Reaction of hydroiodic acid with barium oxide. Hydroiodic, when you see the prefix hydro on an acid, that means it's just hydrogen and an anion. It's not an oxy acid with oxygen in there. So this is going to be Hi with barium oxide. So barium forms a 2+ ion because it's in group 2. Oxygen forms an O2- ion, and so barium oxide is just BaO. When an acid reacts with a metal oxide, it forms water and a salt. So it's going to form water. And then the iodide is going to swap places with the oxygen. So we're going to have barium and iodide. And we're going to get BaI2. And then we have to balance it. So we need 2 HIs. And that'll be balanced. Okay, writing these equations, if you're one of those students that wants an A, you need to learn this. If you're just trying to pass the class, you can safely ignore this right here. You need to know what acids are, but you don't need to know how to predict the reactions. Any questions? Because there might be like one question on the final about this. It's not going to kill you. Base reactions. Neutralization reactions are the most important ones. The only other kind that we're going to talk about is the reaction of aluminum with sodium hydroxide. And we did this in lab too. Remember when we took the tin foil and we tore it into little pieces and we went out on the balcony and added, I think we used potassium hydroxide, but all of the aluminum dissolved. Aluminum is one of only a few metals that will dissolve in a basic solution. And so it does that and forms this.